Hello, everyone. Welcome to this stream on active learning. I'm Quinn. I'm a coach at Major League Hacking. I'm going to be talking you through everything that we're going to learn today. I'm super excited. I hope you're excited as well. I'm maybe even going to start in a couple of minutes just to give some time to get through the Twitch ads. I know sometimes those can be killer. But in the meantime, please do check in. I've sent the link in the chat already. I'm going to just pop it up on screen. There we go. Checking in gets you points, and it also gets you swag. You get bonus swag if you checked into 5 events, so definitely do that. The stickers, oh, they're to die for. So I do recommend. Okay, and yeah, welcome. As a quick kind of overview, this is going to be a stream on active learning, which is the idea of how can we enable our model to indicate which data is most useful for it to learn from next, especially when labeling data is expensive. This is a really useful way for us to know how to most efficiently train our models. Yeah, it's super cool and intuitive as well. So hopefully we're going to see some nice visualizations, and maybe we'll get a dashboard out of it as well. I often say this in my streams. I'm like, let's build a dashboard, and we get to kind of the end of the stream, and it's like we haven't even started on the dashboard. So we'll see how much time we have, but hopefully we'll get somewhere cool like that. And yeah. With that, I might get started. Great to see you here, Vincent. I enjoyed the Today in Global Hack Week stream just now, which Vincent was streaming, and that was really cool. And it's great to have you here too. All right, so I'm gonna maybe give it 1 more minute, but if you are desperate for something to do and you're wanting to get started already, I appreciate the eagerness. Open up VS Code or your IDE of choice. You can use Colab if you want. I don't think there'll be any issues with doing that. We're mostly, in fact, I think entirely just working in a notebook. So that should be good. And also, as a heads up, if you see me looking this way, I'm looking at the comments. So do not fear. I am paying attention. I haven't abandoned you all. So do not worry. Okay. And yeah, I'm gonna give it maybe a couple minutes. Maybe we'll get some tunes on, and then we'll maybe start in 1 minute. Let me know if the music's too loud or quiet. Maybe lo-fi. Lo-fi is good, right? See how that goes. All right. Okay. Right. I'm going to suggest that everyone gets. Let's get started. I think I'm going to suggest that everyone gets VS Code open. I have my VS Code open already. I see we've got a couple more people who joined since I last mentioned it. So please do check in if you haven't already. You get points and swag by doing so. So I do recommend that. I'm going to turn the music down slightly. It's quite loud for me. Maybe it's just me. My volume's up too loud. Let me know if you can't hear me. If you can, that's great. Okay, so I've got VS Code open. Maybe before we get into things, actually no, let's get ourselves set up, and then we'll talk through kind of what we're doing. I think that will be a better way of doing it. So what I'm going to do is I'm going to make a new project. I'm going to do that by going into my projects folder, and I'm going to call it, we'll just call it like active learning. Okay, and I'm going to select that folder. Awesome. For anyone who missed that, you can click open folder to do this, or there is a shortcut which I used, Control-K, Control-O. But this has got me set up in its own little folder. You can also do this in the terminal. I tend not to bother. I think this is quicker, but you know, it's up to you. And we're going to create a virtual environment, as is typically the way you do when you start a project. And here we're going to be working in Python, by the way. You can use whatever you like. You can use Conda, that's pretty popular as well. But I'm just going to make a very simple virtual environment here, and I'm going to call it maybe active, and then I'm going to save it in a .env folder. What this little prompt flag means is that in the terminal here, it will show up as active. So if I'm using a couple of different virtual environments or whatever, it's going to be really clear for me. But we still got the kind of conventional .env up here. Awesome, and we'll let that run for a bit. Okay, cool. And now we need to activate this. This is going to maybe vary depending on your operating system and also the terminal that you're using. I'm using Windows and Git Bash, which is, I think, pretty unconventional. So you might have like a variation upon this, but this is the command that works for me. If you have any issues activating your virtual environment, let me know. Often VS Code will have like a little pop-up down here, which will allow you just to click and activate it. So that can work nicely as well. Cool. All right, so hopefully we are in a fresh project and we've got a virtual environment set up. If any of this is new to you, let me know and I can help diagnose if you've got problems. But hopefully this is not too strange. And we're going to make a notebook, and maybe we'll just call it experiments. And this is where we'll be doing all of our bits and pieces today. And hopefully we're going to build some useful functions and things that if you want to use in future projects when you're training models, you can just take them from here and put them into various scripts or whatever you like. So hopefully it's going to be really useful and reusable in your hackathon projects as well. Could I zoom in a tad? I absolutely can. Is that enough? I can go bigger, but then like I'm losing screen real estate very quickly. Hopefully this is fine. Hopefully this is fine. You can let me know. Okay. Cool, cool, cool. Okay. This is perfect. Great. Okay, so I think before we get into any coding, it's useful to have a bit of an idea of what we're doing. And I'm just gonna move some tabs around before I get too into it. Okay, perfect. Okay, let's get a bit of an overview of what we're doing. So first of all, active learning, which is what we're looking at, is just a way to train models faster with fewer labels. And the way that we do this is we do this by allowing the model to choose which unlabeled examples to ask about next, right? And I'm putting that in quotes. Models can't really speak to us. Well, LLMs can. The kind of models that we're going to be working with here won't be speaking to us, not properly at least. Cool. And the reason that we do this, instead of just labeling everything, we prioritize the most useful items first. And this is typically the ones that a model is most unsure about. Or potentially items that represent some new pattern, which we might also call a distribution. Cool, and this is hopefully making a little bit of sense, but we can make this like really concrete. And so the example that I like to use is, if you've ever played the game 20 Questions, maybe give me like a thumbs up in the chat if you have. Hopefully you have. It's basically the premise, for anyone who hasn't, is that one person thinks of something. It might be an object like a pencil, or it might be an animal like a bird. And someone else, or maybe a group of people, have to guess what it is, but they only get 20 questions. 20 questions is fun. I'm glad someone knows what I'm talking about. And so when you are making these guesses, you could guess, like, for example, a good guess, I think, might be, okay, is the thing that you're thinking about alive? And I might say, yep, it is alive. Yeah. And then okay, right, it's not going to be a rock or a pencil or whatever, right? But let's say, for instance, for example, that someone guessed, okay, is it a plant, right? It would then, in my opinion, be pretty silly to ask as a follow-up, oh, is it alive? Because plants are living things, right? These are, flora, they are alive. And so the the point of this little analogy is that in 20 questions, if you've already crossed something off, if you already narrowed something down, if you know something already, it's pretty pointless asking a question which doesn't tell you anything new. Okay? And so when we play 20 questions, like what you really want to do is you want to cut down as much of your uncertainty as possible. Okay? And active learning is doing just that. So your model is asking for labels on pieces of data, which it doesn't have labels for yet, that will help it learn the fastest. And this is like an idea of uncertainty. Maybe you've heard me talk about uncertainty a little bit in some of my streams before. Cool. Okay, right. Hopefully that makes a bit of sense. Cool. And the reason that we care about this, I'm maybe just going to make a note of that. 20 questions. Oh, my typing is terrible today. Analogy. Narrow down as efficiently as possible with smart questions. Okay, and we do this for a few reasons. Typically because like labeling data is expensive, right? Especially if you've got like a human labeling it. This is really expensive, and so if we can label fewer items, we save money. We also save time, so we'll put that in there as well. And generally, like we're focusing our attention on the most informative examples. Okay, this is also like more sustainable as like a note, like less compute because we're learning more efficiently. And so this is good for the planet too. Yay! We love that. Okay, so hopefully we've got a bit of an idea of what active learning is and why we want to do it. Okay, and the kind of mental model that I want you to have in your head is a decision boundary between perhaps two separate classes. You can imagine you've got a blob of data up here and a blob of data down here. And you might draw a line between them and say everything above this line is data up here, and everything below the line is data up here. Okay, and the most confusing examples to us are probably the ones near the line, or maybe even on the line, right? We don't know really which side of the line they fit on. And so in this case, labeling those that are near the line is most useful to us. This is like where the uncertainty is the highest, okay? And so hopefully we're going to be able to visualize that really neatly. And I'm going to say that we should do some coding now, because why not? Okay, so let's just make a code block, and we need some bits and pieces, and I've missed this notably, so maybe we should do some imports first. That would be helpful. And I'm trying to remember what we need to import. Well, installs rather, not just imports. Let's get my terminology right. Okay, well, we want NumPy. This is going to allow us to manipulate arrays. And we want scikit-learn, which is a library that allows us to build models really quickly without coding them from scratch, which would be a bit of a pain. And we want matplotlib, which allows us to do visualizations. And I'm just going to install those for now. There might be some bits and pieces later that we need to install too. We can come to that. Make sure that you do have your professional environment activated. I've actually really confusingly called this active. I should have called it like active learning or something. This doesn't mean that it's active. This is just the name of the environment that I've got active. So poor naming convention from me. I should have really called it the same thing as I've called the project. So don't do what I do. Don't do what I do, everyone. Okay. And while that's going, let's import NumPy. Oh, first you see very interestingly that we're in just a text cell and we really want a code cell. So let's activate that kernel, that environment in our notebook. And that's much better. We can see we're now in a Python cell and all is well with the world. Okay, and let's import, matplotlib as well. Thank you, Copilot. Perfect. And we're going to also import a couple of different bits and pieces that are going to allow us to do some setup. So we want datasets import make moons, which is a function that allows us to make some data in a moon shape. Remember, I was talking about those shapes of data. Well, this is going to make us something slightly more interesting than just, circular or maybe ovular blobs. And then maybe let's import a model. So linear model. And yeah, let's get logistic regression. So logistic regression is a model that allows us to essentially draw a line between two classes, and this is for classification, right? So it's a linear model for classification. And then, yeah, we do want train test split, this here. Okay, I'm going to type that out. And this allows us to split up our data, unsurprisingly, into a train set and a test set. Okay, how are we doing? No questions so far. Perfect. Okay, I hope everyone is following along and happy so far. Okay, so I think the first thing that we want to do is let's generate a moon dataset. Okay, and we're going to call our input data X and our labels Y, and we're going to say make moons. And how many samples do we want? Probably 1,000 is overkill. Let's just do like 600. And we'll have a bit of noise. Let's have more noise than Copilot is suggesting. That's 0.25. These things don't really matter, to be honest. I'm going to set the random state to 42 as well. This is like a seed, which allows us to make sure that what we're doing is reproducible. So hopefully when you run it, you'll get the same thing as me. Although it can vary from device to device because of your hardware, especially if you're on a GPU. But for something like this, just need the CPU, it should be fine. Yeah, okay, cool. And so, let's finish the comment before we start writing the code. We want to start with just a small labeled set, which is like, basically what we're doing here is we are simulating like what we already know, okay? And we're going to split it up. The data that we've just generated up here, we need to split it. And let's do that now. So this is using that train test split function that I spoke about, and we're going to split up our input and also our output, our label. And maybe we'll say the test size is 0.9. And we also want to stratify. I had a question about this yesterday. This just makes sure that our test, well, all of our splits, we could have a validation split as well if we liked, but we don't. But all of our splits have, the same kind of proportions of our classes, right? Our label. And the reason we do this is because otherwise it can make training our model a bit harder. Especially if our training data and our test data don't have the same distribution, it can be a bit funky. So we'll make it simple for ourselves just for this little demo. Okay, and let's fit a really simple logistic regression model. Okay, and we're going to call it CLF for classifier, and we're going to call logistic regression. And we can set the max number of iterations. Maybe 1,000 is good. Okay, and we're going to fit it on our training data. Okay, so this is the data that we split off from our main data. If we wanted to, we could like print, yeah, there we go, the set size of our training data. So if we run this now, for example, let's do it. Ooh. Yeah, don't be me. Install the IPyKernel package if you're going to be working in a notebook. So we'll let that run. See how that goes. While we do that, I'm going to grab some water. Stay hydrated, folks. This might take a minute. What we're going to do in the meantime is we're going to build a grid, and this is going to be to visualize our predictions. Oh, that's number 4. And for anyone who went to my stream yesterday, some of this might be feeling really familiar. That's okay. I promise you we'll get to some new stuff in a minute. But this is going to be a really nice demonstration for anyone who did see it of this idea of the decision boundary and the uncertainty that is associated with it. We use lots of these kind of little tips and tricks that I'm using now to build a grid, for example, yesterday too. But we're not going to do exactly what Copilot wants here. Ooh. It tried to run after I was not finished writing all of this, so that's okay. But we can see here that in our training set size, we have 60 samples. And you might be thinking like, oh, that seems really low. And that's the whole premise, right? We have simulated this. Like, we don't know very much. What are we going to label next to maximize what we do know? Okay. And so let's continue making this grid. And so we're getting the little boundaries, basically the corners of it, and we're adding in some padding. You can see that here, to make sure that we don't have anything trying to plot off the edge of our grid. Okay, and we'll do this as well. Plus 0.5. Okay. Now, this is not quite done. We also want, let's split this up a little bit and make it clearer. Yeah. Okay. This is slightly better. Okay, so we've done one dimension here. This is like our x-axis, if you like. So let's grab our y-axis as well, and it's going to be basically the same thing. You can see here, Copilot has worked it out this time. Great. Okay, and it's not completely happy with me. That's because we are missing a bracket, but that's all okay. We can fix that. Okay, and then we're going to make the grid using this kind of mesh of points. So that's what this does. And then we will throw in the probabilities here for each of those points in our grid. Okay, and so what I'm doing here is I'm building this kind of like nice visualization, hopefully, that will show the probabilities that we have associated with each class at different points on the grid. And this might not make much sense to you now. It's okay. It wouldn't to me either, but it will once we plot it, and I'll go back and talk about this code and how it works. Okay. All right. And just to be like super clear, let's define an uncertain band. And this is going to be where the model is unsure, i.e. near 50-50, right? So if you're like, it's a coin toss, I have no idea, your guess is as good as mine, right? Like these kind of sayings, what we're really saying is like, oh, my probability with it being in class A or class B is like 50-50. Could be in either one, yeah? And so we will say uncertain equals probs, and we'll do, so this is good from Copilot, this is kind of what we want, but let's be slightly stricter. I want to say 0.45. And yeah, 0.55. This means that we're symmetric. Otherwise, it would be a bit weird. Okay. And let's plot. So what do we need? We do indeed need the figure size. That will do. And then we want to plot our decision surface. So this is just a function that's going to help us do that. And we'll say, yeah, levels equals 20. We'll let it just use the default color map. I don't really care about that. We want the alpha to be quite low, because otherwise it's going to just make everything really hard to see. Perfect. And then we want to plot our decision, our uncertainty band as well. So this is our kind of probabilities for all of the classes across the whole backdrop. This is just going to be this band that we defined here. Cool. So that's going to be much the same. And we need uncertain in here. And I think we just want 2 levels. Okay. 0.5. Yeah, and 1. Hopefully this is going to be like clear. We might be layering too many things. If we are, we can turn some of them off and just like plot some. We'll see how that goes. So I'm going to make that mostly transparent as well. Hey, no worries at all, Tammy. So we've just been talking about active learning. What I'm going to do is once I've run this code, I will shove this onto a GitHub, which you can just clone, and then you'll be caught right up with us. We're near the end of this code cell, and then you should be able to do that. What I will say is that once we've run this, I'll explain the little plot that we're making, and it should become really clear. So anyone who's joined late, don't worry. We're going to talk through what active learning is with a nice visual example as well. Cool. Okay, so where are we at? We've plotted our decision surface and then also our uncertainty band. And now let's plot our points. So let's say plot.scatter. Yeah, this is kind of good. Okay, so it's accurately worked out that, yep, we want our unlabeled data here. This is the one that we split off here, right? So we've got our training data and our unlabeled data. And it's worked out that this is the x dimension and this is the y dimension, i.e. horizontal and vertical. Great. It's making them gray. That's fine. Copilot is so good today. Sometimes I think Copilot is just crazy, but I don't really want that. That's fine. And maybe we'll make these like a little smaller than the default size, because otherwise it's going to be quite cluttered. So we'll make them size 12. And yeah, we've got them unlabeled pool. Yeah, that's okay. And semi-transparent is fine. Yeah. Okay, and then we also want to plot our labeled points, and that's going to be exactly the same. So actually, let's just, instead of using Copilot, we'll copy and paste ourselves. Okay, so we want X train here instead in both of these, and then maybe let's plot them in I don't know, let's say the color is going to be Y train. Okay, and then so what we're saying is pick the color according to the class that we're putting them in, but we do now need a color map. So we'll put that in here, and we'll say cool warm. Okay, perfect. And I think I'm fairly happy with this. We can make them a bit bigger, maybe like 45. And we'll call them labeled. And that should be fine. We maybe don't want alpha to be quite so low for these, so let's just do that. Yeah, perfect. And we could do an edge color here. I don't think we want colors plural. I think that's wrong. Yeah, we'll say okay. Fine. Okay. Cool. So we've plotted plot our points, setup and shading, and this is good. Okay, perfect. And then let's plot our legend, which is going to be located in let's go to the upper right corner. I hope all of this like does turn out as beautiful as I'm expecting it to, because it's going to be a real letdown if not. Yeah, we can call it that. I mean, it's fine. And then yeah, X and Y levels are feature 1 and feature 2, and plot show. Okay, so I'm going to run this. We should maybe like actually, let's just make this a nice rhetorical question. Which points should be labeled next? Perfect. So let's run that. Okay. Nice. So we could make this a different color. I think that might be clearer. Yeah. Okay. Can we go like orange? Yeah. You know what? I don't even like that. Let's just remove that. We're fine. Okay. Perfect. So this gradient on the background, you can see we've got little lines here. These are the levels that we've got. So it's actually not a complete gradient. It's according to the level that it's in. And up here, this is saying, okay, it's in this blue class. And down here, we're saying, yeah, it's in that red class. Okay. Which is perhaps intuitive, right? you can see that we've got a class here of the blues and a class here of the reds. And you can see, hopefully, this moon shape, which I spoke about earlier. This is what this function does. It makes these moons. Okay, and this makes sense, right? We've got just a linear classifier. So it's basically drawn a line through the space and said, everything this side we're going to classify as red, and everything this side we're going to classify as blue. And this gradient is the probabilities, how certain it is. So anything over here, it's like really sure that it's blue. And everything over here, it's really sure that it's yellow. But as we get in the middle, we can see it gets kind of confused. And this decision boundary here is where it's in that range of like, it's a probability somewhere between 45 and 55%. It's basically 50-50. So it's a bit of a coin toss in the model's head as to whether it should be on this side or this side, okay? And that probably makes sense to us because we can see like, okay, yeah, probably these are part of this blue moon, but like they're over here, and you know, like these are definitely part of red, but like these ones here, kind of confusing, don't really know. And there's limits to a linear model in this case, because what we really wanted to do is to go around like this, yeah? But we can see, okay, the most confusing points are the ones in this area where we're just not very sure, right? We're not exactly sure where to put our line in here. And so what points should we label next? Well, in this model's opinion, it would say these are the ones that it's most uncertain about. And so it would ask for the labels on these. So if we're training this model to learn as efficiently as possible to get its highest accuracy, which is not going to be that high because it's not a very sophisticated model, but if we were to do that, it would want to learn what these labels are next in this nice line here. And that's the premise of active learning. For anyone who missed it earlier, active learning is basically your model saying, these are the points which I'm not certain about. Can you tell me which classes they're in? And that will help me update myself better. Okay? And so we can make our models learn quicker by doing this. Sure, right? We could label the whole data set and just be like, done. But that would be really expensive in many cases and pretty slow and inefficient in general. And so we don't always want to do that. And this is the premise of active learning. Great. Okay. Looks like we don't have any questions so far. So I'm gonna maybe just relabel this to section 0 overview. Perfect. And let's commit this. I'm going to cheat and use, let's put another. Okay, don't do what I've done. Make a git ignore, guys. Git ignore. There we go. And in here, I want to have our virtual environment, because otherwise it's going to track that, and that's going to be really confusing. And hopefully, yeah, there we go. It's no longer tracking it. So if we hop on over to our version control, hooray, it will get rid of all of these 10,000 plus changes. And we might have to let it think for a second here. Oh dear. This isn't great, you know. I assume it's upset because I yeah, let's just, there we go. Okay, fine. It was still trying to commit. And it still thinks we've got a lot of changes in here. I don't think we do. But something's going on. Am I going crazy? If anyone's spotted what's going on with with my source control, let me know. But oh, I see, they're staged. Okay. Oh no. I'm not a big Git guy. This is why I should go along to Way's get good with Git workshops. Is it Way who normally does them? I feel like it is. Okay, this is useless. I don't really want to commit all of that, is the problem. Yeah, I can see that. Thanks VS Code. Discard all changes. It's not really what I want to do, actually. That might just delete everything. It's okay. I've got this saved somewhere else. If it deletes everything, so be it. Oh, it's stuck thinking again. This is a lesson. This is a lesson. Don't be like me. I see we've got some questions. While I'm letting this think, you know, I feel like that's not what I want to do. Okay, let's see. We've got some questions in here, so we'll answer those while this thinks. And if it doesn't decide to sort itself out, I'm not going to faff around with this. I'm going to just make a new project and copy and paste it. So, and then I'll commit for you all. We've got some questions. Right. What am I working in? Collab. I'd like to get started with this one too. Yeah, this is VS Code. I think someone's helpfully answered your question for you. I do recommend VS Code. Very beginner friendly. No worries at all. I'm glad you're finding it interesting so far. I'm sorry that we're getting held up here. What I'm going to do is for anyone who missed the start, we're going to reproduce what we did earlier really fast. So I'm going to make a new project. Not here though. I'm going to make it in... Oh no, this isn't what I want. Oh yeah, this is better. Okay, right, we're going to head along to our projects, and we're going to make a new folder. I'm going to call it active learn, and we're going to open that up. All right, speed run what we've already done. That's what we got to do right now. Okay, perfect. So for anyone who missed it, this is the the run through again, but I will do it much quicker this time because I don't want you all sitting around. I'm going to call it active learn. This time we're going to actually name it something sensible. Perfect. That's going to pop up there. Hooray. And I'm going to activate that. So we're going to call up the folder name. And now we can see it's active. Hooray. Okay, perfect. And then we will pip install numpy. What else do we have? That's .lib. And while that runs, I'm going to make a git ignore. I'm going to put in, there we go. Fix my mistake from last time, and we'll call this experiments. This is our notebook, and this is where we had all of our lovely content. Oh, I'm talking as if you can see. I haven't shared my whole screen, have I? You need to tell me if I'm just like waffling away while I'm in a different tab. Let me reshare my screen. That would be much better. Okay, share screen. Okay, great. And I'm going to select this kernel, and I'm going to go and copy across our notes because I think they were helpful. And let's put in the code as well. Okay. Sweet. Right. We're now at the point where we were. Everything is still installing, but it's okay, because we can initialize this as a repository and we can commit our changes. We'll just call this section 0 and we'll commit it and we'll publish it and we'll publish it to a public repository. Oh, I'm still not sharing my screen. What a rookie error. What a rookie error. Okay. Right, for anyone who missed it, This is better now, and we don't have a completely destroyed source control, so that's good. Perfect. Right, our installations are finished, and it seems happy. We're installing ipykernel. That's good. You'd have to do all of these installations yourself. When you run this, it will tell you, oh, you don't have this installed, so you can just pip install them for anyone who missed that initial step. But anyone who wants to follow along, let me just link the GitHub to you now. Just gonna find it. Okay. Right, there we go. Back on track, back on track. Right, and now we're back to where we were. This is great. That most recent change, I think, was just the code running, so we'll ignore that. We don't need that. And hopefully we're all happy and ready to move on to section 2. So this is going to be where we build our first attempt at something that's a little bit better than just randomly asking. Okay, we could randomly be like, oh, tell me the label of this one, tell me the label of this one. It's not very useful. We want to know the uncertain ones, and so that's what we're going to do in section 2. And we're going to call this like first look at random versus active learning. And we're actually going to do this with we'll work with a random forest. This is because logistic regression is linear. As we can see here, it just puts a line straight through it, and that's not actually going to be very useful for us. We want to learn a more detailed curve than that. So as much as that was useful for our initial demo, let's use a slightly better model. Random forests are non-linear, which is perfect for our use case. It also gives class probabilities just like logistic regression does. And I'm not going to get into the ins and outs of different like machine learning models, but it's going to be hopefully really intuitive when we plot a new chart just like this. Okay, great. So we've got some setup to do. And we're going to do all of our usual imports. And I'm going to go fairly quickly from now on because I want to get through a decent amount of content. If ever I'm going too fast, you get confused, let me know. I'm also going to commit semi-regularly so you can grab the bits that you didn't manage to write out yourself. Cool. Oh, there we go. Dot display. Clear output. So I'm pulling in some like visualization tools that are going to make our lives a little bit easier. We've actually already got my moons, so we don't need to do that again. It's just like, oh, let's re-import things. Nope. We do want, however, metrics, and we want to import accuracy score, and why not F1 score as well. And then we want k-means is another algorithm that we could use, but like most likely we won't. We'll leave it there just in case. We might want to do a little comparison, for example. And so we're going to import a random forest classifier. This is an example of an ensemble classifier because it uses many different models. We're also going to import, we can import some like other bits and pieces. There are like a whole bunch of different classifiers. Like you could also use, logistic regression is another classifier. But we could use probably another one that you've heard of is this. Let's get the American spelling in there. Hurts my heart. Okay, and what I want to do is I want to make like something interactive because I think that's going to be cooler for everyone here. So let's try and import ipy widgets as widgets, and we might need to pip install ipy widgets. Widgets. Do we want actually all of these? We don't really want all of these. Let's get rid of these. I want hbox, bbox, button. I want int slider, drop down. These are all just different bits and pieces that we can play with to make nice outputs. Is there anything else that we want? maybe layout. Yeah, okay. And we will, oh, and then let's also say, let's make a constant, which is true. And then we'll say except, we'll just say except exception. Widgets equals false. Great. And let's also set a random seed. We'll do this with NumPy. And we'll set it to 42. Okay, this is our little setup. Just add like setup. Perfect. Okay. Right. Just looking at the time, we've got just over an hour, and I want to get through quite a bit. So we've got some helpers that we're going to make to generate our data and also our states, i.e. whether we're doing active or random learning. And I might... Oh, we also need to do some of our like output setup with widgets and plotting. So what I might do is copy and paste in some bits and pieces here. And then we can type through some of the more interesting code ourselves. So I'm going to do that, and then I'll commit it for you all. So this here is our data and state setup. It's got some occasional comments if you're interested in all of this and how it's working. But basically we are generating the two moons as before, and then we're stratifying it as before into our labeled main train set and then our unlabeled pool. And then we are also keeping track of our scores, obviously, but also our classifiers and the states, i.e. whether or not we are using active or random learning and the kind of in-between bits and pieces that we need for that. So I'm going to run that. I don't think we need that there. There we go. Perfect. Great. Okay, this is run. We've initialized. I would just ignore all of this. Perfect. This is our data split, so not super needed. Cool. And then we also want some plotting helpers, and also some other little bits and pieces. I'm going to paste these in too. These are going to help us with how we are selecting the next label. So again, like k-means, we've got some kind of like infrastructure for that here. I don't think we'll use that. But when we want to plot our decision boundary, for example, this is something that we did earlier. We are constructing it using this grid, and then we are visualizing again using the band over here, which again we discussed. We could change this to be tighter if we wanted to, but for now we won't. And then we're plotting our different points, and we're also plotting the learning curve. And this is just going to plot the accuracy over time on the test set, which is another set that we split out separate from our train and also our pool. This is so that we don't have data leakage. And this is going to show how quickly our model is learning as we put in labels. And hopefully we'll see that as we put in useful labels from active learning, it trains to be more accurate quicker than random labels. Okay, so these are, again, just some helpers to make things easier for us to do all of that. Cool. Okay. Right. Perfect. Let me know if anyone's got any questions so far. Otherwise, I will set this off to run. No, not set this off to run. I will commit this even. You can tell that it's getting towards the end of the day for me. It's not too late here, but it's late enough that my head is kind of slowly exploding. So. Okay, I don't see any questions. Cool, so I will commit this data and plot helper functions. Great. Okay. Perfect. Now, we need to build our main interactive loop. This is where I want us to have all of our different buttons and bits and pieces, which we're using our widgets for, and hopefully going to make it really cool for us to visualize. And the first thing that I want to do is make a function. And this function is going to be called step learners. Great. And we will set a batch size by default. And we're also going to have this flag called use diversity. This is going to encourage our models not just to deterministically pick the most uncertain ones, to be a little bit more shaky, if you like, so that even when we've got I mean, how to explain this simply? If you come across reinforcement learning, maybe you might have heard of this idea of exploitation versus exploration. And so our model might think that it's got a region which it's not very confident on, right? But actually, there might be an uncertainty associated with that. And so it could be wrong, basically, is my point. And so we do also want to make sure that it does check some other points to make sure that its guess is correct. For example, going back to our 20 questions analogy earlier, if I asked, okay, like, is this a plant? And someone said, yes. And then I said, okay, so it's an alive thing. I maybe wouldn't necessarily ask, is it alive? But it could also be like a dead plant, for example. That would be, I think, a really mean and niche way of doing it. But we make certain assumptions, and our model might have made an oversimplifying assumption or a wrong assumption. And so we want to still explore to make sure that what we've said before is true. And typically, we want to do a little bit more exploitation in this case. We want to be like, okay, we want to make sure we pick the most uncertain ones as a priority, but we also want to just, alongside a small proportion, maybe we'll verify. Now, this is crazy from Copilot. It's just going mad. And it's not done a bad job, but we'll talk through this. So the step learners function is every time we say, okay, we've got to this point up here, and we want to collect some new labels. We're not going to collect a label at a time. We're going to collect a batch. And so we're going to call, as we collect some more labels and then feed it into our model to improve it, we're going to call that a step. And so each step, we're going to collect a batch of new labeled points, and we're going to train on them. And so we have our batch size here. Hopefully that makes sense now. But this is going to be doing the step through. Okay, and I want to make some new variables, and I'm going to call them we're going to call them this. And the reason that we're doing this is we're splitting up A for active learning, and then we're going to have R for random as well. Okay, and obviously this is the labeled set, and this is the unlabeled pool, which we used earlier. So I'm going to just accept all of those suggestions from Copilot. And then we do actually want, this is kind of freaky from Copilot, but we do want these variables as well. We'll get to them in a minute. So the first thing that we want to do is we want to train our current models. Okay, and so we're going to say our random model, and we will call train and score. Which is this function here. There we go. And this is going to make our classifier, fit it on all of our labeled pieces of data, predict, and then it will score based on those predictions. So you can see here we've got the accuracy score where it's comparing our true Y values in the test set. Yeah, we are predicting on the test set. I'll just double check that. Yeah, we're predicting on the test set, right, which is different to our labeled training set. And so we're checking, okay, how many of our predictions actually match the true values. And we're going to do this with the accuracy score function, which, just as you can imagine, calculates the percentage of labels that we've guessed correctly. Okay, so this is the function that we need. And let's pop in all of our different sets of data, which hopefully you would have seen up there. And we will do the same for our active learning set. Okay, and then what we want to do is we want to say, for our active learner, we want to select by uncertainty, okay? And this is that idea we spoke about where, okay, the model's not really sure. It's at that 50-50 boundary. We don't really know. And we're also going to include, diversity, optional diversity, based on this parameter up here. Okay. So let's get started. All right. I'm just going to check if we've got any questions. Doesn't look like it. Looks like we're fairly happy. I'm checking. We're about an hour in. Okay. And I want to get to the point where we're actually applying this in practice. So I think we should have time. We should have time. I'm feeling fairly confident. I might speed through some of this, and then I'm going to rely on you all to tell me if there's something which you don't understand. But I'll try and explain things kind of as we go. Okay, perfect. Right. And let's get index A, which is our the indices for our yes. Okay, so this is going to get out the indices for our uncertain points, and we're going to do that using this function which we defined up here. So let's go back and look at that again. There we go. Okay, perfect. So we've got this parameter up here which we can use, yeah, this is one that I spoke about a little bit earlier when we were talking about k-means and whether or not we want to use it. In this case, we're just going to be using random forest, so I don't think we'll actually end up using this a whole ton. Although perhaps we are actually. So if anyone was in my stream yesterday, we spoke about how we can get uncertainty from our model. And there are like a whole bunch of different ways to do it. So in, for example, logistic regression, we have logits, which are just kind of raw scores that are associated with our points. And then we transform those using a sigmoid function into a probability. So some models really nicely have the uncertainty kind of spat out for us. In this case, we're not doing that. What we're doing is we are fitting k-means, which is a clustering algorithm, and we're using a whole bunch of different candidates, and we're seeing kind of where there's disagreement, and then we are fitting based on, we're deciding based on that, okay? So it's a little bit like unconventional because it's not like our model just directly associates probabilities with our predictions directly. Yeah? Cool. Okay. And for anyone who was still like, oh, why don't we just use the logistic regression model because it just spits out probabilities? And that is true, it does. And it would be like simpler. But in this case, it wouldn't demonstrate what we really want to show because the line is completely linear. And in this case, we do kind of have a bit of a non-linear thing going on here. It would kind of be fine. But what I expect we would see is that random and active learning would gain similar amounts of knowledge in each stage, because really it's going to hit an accuracy limit, and the accuracy limit is basically just the line, right? This line is already pretty much as good as it's going to get, and increasing the number of points that we have, even on the decision boundary, is not going to improve the line a lot, because it doesn't have much space to improve. The things which it misclassifies, it's always going to misclassify based on its structure. So it's a bit of a different problem. What is going on here? Let's see if we can't work this out. Yeah, Okay, this is good. So we've got the indices out. We also want to pass in a couple of other parameters. So we want to say, yep, use diversity. And is there anything else that we need in here? Do some questions. Would it be possible to improve the model by adding more dimensions? Do you mean the logistic regression model? I don't think you could add more dimensions because it's already taking in all of the dimensions, right? Our data here is two-dimensional. So we've got x1 and x2. We call them feature 1 and feature 2. You can call them what you like, really. And we've represented them on the x and y axes. But we're already feeding both of these features into our model. It is literally just the like structure associated with the model. Like the definition of logistic regression is that it's not going to deal with this. At least that's my off-the-cuff take. I'm sure there are like weird adaptations, which, you know, I don't know. Maybe I'll Google this. I don't think such a thing exists where you could adapt. Yeah, no. So, I mean, what you could do is you could create new features which are non-linear combinations of the features that we have here. So if we had x1 squared and x2 squared, and then we could also have x1, x2, then we would have a non-linear classifier. But really what we're doing is linear in the features. It's just that we've constructed non-linear features. That would probably improve its performance. Yeah, it probably would. So that is an option. But this is going to be better, to be honest. Random forests are awesome. So hopefully this is going to be great. And I feel like we also maybe want to put in the number of candidates that we want in here. This is how we kind of get this idea of uncertainty. We have a few different candidates, and where they disagree, that's how we get out the uncertainty. Once we've run this, we're going to talk through the different types of uncertainty and how we can generate these labels in an active learning paradigm. I really want to demonstrate this working first, and then we'll kind of get to that. I think I might cheat again and do some copy and pasting in a minute, especially for how we render this. So we need a function that's going to render all of this with our interactive widgets and bits and pieces, which is not really the focus, so maybe we'll just paste that in. Cool. And what we want to do is we want to get out our new points, and we're going to do that using our pool of unlabeled points, and we're going to put in the index. Okay, so pop that in there, and we will do the same for our labels. Perfect. Okay, and now we want to combine this in, and we could do this. Is this going to work neatly? My concern is that... Oh yeah, no, yeah, this is going to work really neatly. This will be great. So what we're doing is we're just stacking on top, literally stacking. This is something that we're using via NumPy. We're stacking on top of our previously labeled data, and we're stacking our new data on, right? So now we have all of our nice new labeled data, and of course we have to do the same here. My biggest concern is that we are adding new labeled data, right? We have the labels the whole time realistically, but in this case we're emulating the idea of like, oh, we've asked an expert and they've labeled it for us, right? In this case though, we're moving it from our pool of unlabeled data here, but it's still in the pool. So in theory we could grab it again, and I don't really think we want to do that. So yeah, okay, this might work. This might work. My initial thought on how to do this best would be to mask it out. But we can try and just run it via deleting it directly through the index. So what we're doing is we're saying, okay, now that we've moved this data from the unlabeled pool to the labeled pool, let's delete it. And this should work. This should work. I'm feeling good about this actually. Okay, great. So that is for our active learner. And now we need to do our random learner. And this is going to, yes, select, let's be specific. It's going to select uniformly at random. It could select at random under some distribution, but we're not going to do that. We're going to be just truly random. Okay. And again, we've got a function for this, which Copilot has picked up on nicely. And so, as you can imagine, this one is slightly simpler. There we go. It just basically, based on if you've got n to pick from, it's going to just pull out a whole bunch of random indices for us. So that's really nice and good. Perfect. Is this correct here? Yes, yes it is. Okay, great. And we're going to do much the same thing as before. So we're going to say x new r, y new r, and then we're going to pull them out by index. We're going to stack them, we're going to concatenate them, and then we're going to delete off from our previous unlabeled pool. Okay, great. Okay, now that we've done this, we can score, but we want to do it after adding the new batch. This is so that it goes on the learning curve. Yeah, great. And so we're going to train and score, and we're going to train and score again, and then yeah, we will append to our history for each of our models. And have we pulled in all of the data that we need? Yes, this is good. I'm fairly happy with this. Okay, I hope this makes sense so far. That is the step learners function. Okay, and maybe we'll oh no, don't do that, please no. Okay. One step. One step of learning on our batch. On batch size, new points for both active and random learners. Okay. That's good. Okay, and now we need a render function. I don't even think we need to return anything out of here as much as Copilot is eager to do so. We need a render function, and it's going to be long and kind of horrific to type out because it's going to have loads of buttons and whistles. So I'm going to paste it in again in my true kind of slightly cheating fashion, with the hope that we get somewhere interesting. Okay, it's using a different constant than we defined earlier, which is fine. We can fix that. So what it's doing, let's just very quickly go through it, is we're clearing our output space, and then we are training and scoring our models initially. We're plotting all of our different boundaries, and then if we've got widgets enabled, we're allowing people to slide various different sliders and model options, which we can pick from, and then it will update, hopefully. So we'll give that a run. What I'm going to do is actually commit this first. Yeah, let's commit it first, and then we can run it together. So we'll call this section 1. Neat. Okay. This is good. And now let's actually run the thing. So let's see, what have we done? We've got a function that allows us to render. We've got a function that allows us to take steps. And I think it's basically all going to come together. So I want to first reset the state. This is a function that we defined earlier, which is going to make sure that we've got a nice, clean playground, if you like. And maybe we'll use a handful of different seeds. And we're going to call this random forest. This is the model that we're going to be interested in here. And we can also set like a bunch of different other like hyperparameters. So we'll set the batch size. We'll say that the target is going to be 300. So this is, as Copilot has guessed, the target number of labeled points. And we're going to have a button that will allow us just to train up until that point. And we'll also say use diversity true. Okay, great. And now what we want to do is we want to say whilst the length of x label a, so the training data that we have for active learner, which is labeled, while that's less than target, and the length of x pool a is larger than 0, i.e. basically make sure that we've got some stuff left, because otherwise we could set this to like 1 million and it would get really upset with us. So let's not do that. So we're basically saying, okay, have we reached the target yet? If not, let's step. And we're going to have, batch size, diversity. Great. And I think actually, let's put this outside of the loop. And I'll run it. This is not looking optimistic to me. It's possible that we do need this inside the loop. Okay, no, this is not what we want. It's going to keep having a pandemonium. I think we need to call things in a different way. I actually think, yeah, I mean, in theory, so this does work, to be fair. This is demonstrating, I mean, it spoilers a little bit. This is demonstrating kind of what we want to show, but it's not very interactive. It's not actually calling our nicely set up stuff here, which is, to be fair, I misspoke earlier, not within the render function. So it should have just run when we ran this. I'm a little bit upset by that. I'm going to delete this. This is just confusing and not helpful. Oh dear. This is one of the things which I always find when I'm dealing with like interactive outputs in a Python notebook, is they just don't behave as you expect them to. Yeah, I'm gonna actually, I've got a different set of code that is gonna work beautifully here. So let's just, it's probably something to do with how we are clearing the space or not. But like I found historically that it can be like notoriously finicky dealing with due to the notebook widgets. So I won't spend too long here. But this, I think, will be a little bit nicer. Let's give it a go. No. Okay. Gonna do some live debugging. I'm gonna let my brain refresh while I check some questions. And then hopefully I will have a euphoric moment and work out what is a eureka moment even, and work out what's going on here. It's not in fact to do with this. That is because it should be widgets and not widgets available. So when I committed that initially, that was wrong. Let me commit this again. So this is like updated section 1 interactive output. This is theoretically more correct, but still not working. It's always annoying when it like doesn't throw an error. Harder to debug. Yeah. Okay. Let's think a little bit more deeply here. Okay. You know what? I think our step learners function is fine. I don't think this is the problem. I think we definitely have a problem down here. I'm wondering if it's like something to do with my notebook setup. If anyone else has pulled the most recent set of code, maybe you can tell me if it works in your environment. It might be like a. Sometimes I have like kernel bugs and stuff. We can give that a go. If in doubt, you know what? Restart and run all your code again. We'll let that run for a second. We'll see if we get anywhere. Okay, wait. This is so much better. This is so much better. This is great, in fact. Okay, so I think it was like a runtime problem. We've got an error, which I'm happy with. So render got... Okay, so this is Copilot just being... Oh no, this is not Copilot being stupid. This is the code that we pasted in. Oh no. This is using a slightly different version of render. So let's fix that. So let's look at render. What do? We clear the outputs, great. And then we train and score everything, okay. And then, you know, I actually not sure we need use diversity in render at all. Maybe I kind of want to check. I kind of want to. I mean, just like as a little precaution, I feel like we should have an here that this I think is better. I'm gonna say we can remove this and also this every time we're in render, because we don't need it in render. When we're rendering, we don't need to know whether we're using diversity or not. So we'll delete that as well. And let's try rerun that. Okay, awesome. Yeah, perfect. So we can see here that we've got our very, very simple initial attempt from Random Forest, and it's gone, okay, it's drawn this like a very cursed line, but it's saying, yeah, it's basically overfit because it's only got, what, 6 pieces of data, and we've got exactly the same initial label data. We've got 12 pieces, 6 in each class for both the random and the active learner. Okay, and we can see that we've got the same accuracy and same F1 score, etc. This is okay. Like, to be honest, given we gave it 6 points of data, an accuracy of 82% on the training set is really good. But let's throw in a batch using our 2 different learning paradigms. Okay, so we've selected the next batch, and there we go, it's regenerated. And so now instead we've got 32 labels, 12 plus 20, and we can see we've gained some more here, we've gained some more here, we did gain some over here as well, and we can see that random has gained some very different ones. And actually, I mean, the difference in accuracy is crazy so far. This is immediately a much better growth. It's gone up from 82% to 93%, and our random has gone up from 82 to just over 89, so 89.5%. So already we can see that this is a much better decision boundary that it's drawn than what we got in random. Random is like, oh, all over the place, right? And we can see here that actually these 2 points here, our random forest up here would misclassify, but it is as a whole capturing this moon and this moon a little bit better than this one is. So let's run another 20 points. Okay, and now we're at 95%, and we can see this curve happening where we're getting these moons. And we can also see that the new points that have been selected are very, very much on this boundary between the two. Okay, less so here actually, interestingly, but definitely here and over here. This again, completely random. You can see it's improved still in accuracy, but we're definitely getting better accuracy out of our active learner with the same amount of data put in. Remember, this is the same amount of data. We can click run to 300 labels and it will train it the whole way up to 300 labels, give it 300. I don't know how many we actually gave it initially. It will update in a second. Or maybe the button doesn't work. That's also possible. Okay, there we go. So we're at 312 and they are both at, well, very, very similar accuracies. In fact, identical accuracies, because they've all got basically all the points, so that's fine. But we can see here that we see much quicker improvements from our active learner. And then there's definitely a point where the random learner catches up. And this is kind of where we're topping out, right? Where our model has learned basically the perfect boundary, or at least as much as it can. And that's when they kind of naturally coincide. But if we can only label 100 points, right? It's a no-brainer that we're going to use active learning. Okay, so you can see hopefully that this is providing very real material improvements, especially on like such a non-linear model like this. Cool. Okay, so great. I think hopefully we're fairly happy now. We do have still in here our highlighted uncertainty band, and you can probably see it a little bit vaguely following around here. That's that green. This little green line here gets kind of confusing here with the layers, but it's this one here, and you can see it following around. That kind of green hue, this is where our model is most uncertain, and that makes a lot of sense, right? So if we rerun this again, oh, it should have reset. I'm kind of sad it didn't reset actually. Why is it not reset? Resets. I can't remember the command for resetting our. I mean, in theory, we should be clearing the output anyway. It's just. Yeah, it's just retaining the states between. It's retaining the states between runs, because we're not refreshing them at any point, and that's because we've set them as global variables. So what we could do, I don't actually know if it would work. Maybe it would work. We can make a copy of all of our learners and the pools of data, and that would probably work. I'm not going to faff about doing that because I don't think we need to. But if you want to do, that's what you should do. Okay, great. So that is the end of our little section 1. And hopefully we've demonstrated something which kind of really works. Okay? And so what I want to talk about a little bit is we brushed over it very quickly when we were talking about the clustering and how we had different candidates and where they disagree is potentially an area of uncertainty. But I want to talk about that in a little bit more detail. And so let's make a new section. We'll call it section 2, and we'll say active learning strategies. And this is kind of the meat of what we really wanted to get to. The kind of objectives for this section are going to be to understand maybe the popular active learning strategies, which decide which unlabeled items to label next. Okay, and I'm going to hopefully keep this fairly light and not too mathsy. Great. And there are maybe some ideas that we've got off the top of our heads. If you have some thoughts on like how we could do this, feel free to throw them in the chat. But like the obvious one that we've spoken about quite a lot is uncertainty first. So we show, I don't know, the top 10 most confusing. I don't know, maybe not show. Show is not really the right word here, but like select top 10 most confusing points. And we could also have diversity first. We've spoken a little bit about diversity. And this would be just basically select a range, a spread out set of points, right? We don't want points all in one area. We want kind of a range of them. In particular, we might say no duplicates. Because we could select duplicates, but we won't for obvious reasons. And then we could also have this idea of committee disagreement, which we also touched on a little bit. And this is where we have like a bunch of different models, and where they disagree is likely a useful place to learn more. Okay, I think that makes a lot of sense, right? If you're familiar with the kind of ensemble models and things. This is a similar premise. Okay, and then we could also have like some kind of hybrid of this, right? Let's keep the capitalization consistent. Hybrid. We could have like a little bit of uncertainty, a little bit of diversity, etc. Okay. Yeah, and we could like, you know, have all sorts of combinations going on here, right? But let's think a little bit about just the uncertainty idea, right? So we're gonna think about some uncertainty heuristics, okay? And let's talk through some ideas. So we're gonna assume, first of all, really, that we have probabilities out from the model, that we have the probability associated with the class. So it might be saying, okay, 90% sure that it's part of red, and only 10% that it's part of blue or whatever, right? So we're assuming that we've got these probabilities. Here's a few different ideas that we could have, right? We could go with, okay, how do we pick the most uncertain ones? Because we said most confusing points, the most uncertain. What does that really mean? Well, we could just say, okay, grab the least confident points, i.e., if the top predicted class probability for an item is low, it's unsure, select the lowest top probability items. And that might sound like a really weird statement. Maybe I'll put an extra hyphen in there just to link this up. So this might be like, what is the lowest top probability? What does it mean if the top predicted class is low? Like, what does that mean? Well, actually, what we're just saying is if it's got, I don't know, 20% for blue and 80% for red, we're picking the red. That is the top probability. I always saying, what class does it most likely fit in? And then what is the probability associated with that? And we do that for all of the points, and then we pick out the lowest ones. So if we had one which was exactly 50-50, the top probability for that item, the top class probability of that item is 50%. It could be in blue with 50% chance, or could be in red with 50%. This is what the model thinks. And that is the lowest possible, okay? Because if we have one which is 40-60, well, we'd say 60% is the top predicted class probability, and 60 is obviously higher than 50. So 50 is the lowest, and this comes back to that idea. Let me pull ourselves up here. That comes back to this idea where we have this 45 to 55% boundary. Okay, this is where we are most uncertain. 45 to 50%. 50% is just completely uncertain, coin toss, right? So we could grab the most uncertain points based on the class probabilities. Pick the ones which are like, it's the most unsure of. Cool. If we have multiple classes, this is maybe less intuitive, right? So we could, if we had multiple classes, do something else. We could say, okay, look at the, and let's label these a little bit clearer. So this is going to be, call this least confident. Okay, and then the next one could be, I'm going to call this top 2 gap. And we're going to say, right, grab the top 2 class probabilities. So let's say we've got like, I don't know, an image classifier that's trying to label fluffy things into whether it's a dog or a cat or a goat or a guinea pig. Okay, and we're going to say, okay, pick, we've got an image of something, pick, and this is our data point, right? Our image is just a data point. Pick the top 2 classes. So maybe it's top 2 classes. It thinks, okay, it's most likely a dog and then it's a cat in that order. And then if these 2 are very close together, right? If it thinks, okay, 40% chance it's a dog, 40% chance it's a cat, and then, I don't know, 10% chance it's guinea pig, 10% chance it's a goat, right? The difference, right, if these are tied, it's really unsure. It has no idea whether it's a dog or a cat. So this is a different way of expressing that uncertainty. So you could take the gap between these, i.e. the difference in top 2 class probabilities. And we could pick the smallest gap. Okay. Now, here is one final idea, and this is going to be called entropy. And this is again in the case where we've got more than 2, realistically. What this does is it looks at the whole distribution, of class probabilities. And you can imagine a distribution, this is something we might call like a density curve or density function. It's describing how likely our classes are in some ways, right? And how confident we are on those. And the way that it does this is if it's, for example, just a flat line, right, across all of the classes, it's basically saying, oh, there's an equal chance between all of them. And if it was like a really pointy curve, it's saying, oh, I think it's very likely to be, I don't know, a dog, and really unlikely to be everything else. Okay, so this is looking not just at the top 2 or the most confident one, but it's actually looking at all of them. And it's saying, if we have a spread out curve, so it's smoother like this, then we're not very confident. We're not very confident. Okay, we're confused. If we have a pointy curve, we're confident. And there is an equation for entropy. I'm not going to get into equations and formulas and maths for now to keep things simple, but look it up if you're interested. We just calculate basically how pointy our curve is, how spread out it is, and then based on that, we've got a bit of an idea on how uncertain we are. Okay, cool. We could also talk a little bit about diversity. There's some different ways of doing this, but I think maybe we'll skip over it. We've got about 20 minutes left, and I want to get something cool going. Maybe something worth mentioning here is this committee idea, and we could form a committee, a bunch of different models, by literally just using a whole load of different like model architectures and so on. So we could have like a logistic regression model, we could have a random forest, we could have KNN, we could have SVM. There's like a whole bunch of different classifiers that we could use. Those are some of the most popular ones, and we could even, like, for example, have the same model with just a bunch of different hyperparameters, or we could use the same model on what's called a bootstrapped like resample of our data set. And I won't get into that, but that's basically where we pick a subset of our data, so a little bit of our data, a bunch of different times at random. So we get all of our data different times at once. And in doing that, we can get this idea of uncertainty as well, this disagreement, right? Bootstrapping is a really cool concept. If you haven't heard of it, I do really recommend Googling it. If I have some time at the end, I'll link you all to some like further resources and YouTube videos and stuff. But it's a really neat idea. It's named Bootstrap after the saying, pull yourself up by your bootstraps, because you literally do pull yourself up by your bootstrap. This is the premise that, it's impossible to do. You can't pull yourself up by your bootstrap. It's silly. You can't lift yourself into the air. But this algorithm does work. And so it's kind of like a slightly satirical, ironic labeling of the name. Okay, cool. And again, we can measure disagreement in a bunch of different ways. We could have like this idea of entropy, but for votes, or we could have a look at the different probabilities that all of the models give us and look at like the variance, the standard deviation. There's like different ways of doing it. But for now, we won't get too into the weeds on that one. This is like really big. Let's make that smaller. Okay, perfect. Okay, so these are some of the strategies that we have. And I maybe have a tiny little demo here. Let me see if I've got something to demonstrate these. Otherwise, I think we'll move on to like a practical example, because I do want to get onto something very tangible for you all. Let's see if I've got something open on my other tab. Yeah, I do. Okay, right. Let me. Can I just yank this across to here? Is that gonna work? I think. Oh no, that's not where I want it. Let's yank it across to here. That's better. Okay, perfect. All right, this is probably a semi-familiar notebook. Ignore the random name. Okay, perfect here. Okay, so we spoke about this idea: least confident, and then margin, and then entropy. And in this case, margin is like not going to be that informative because we've only got two classes, but entropy will be. And so you can see here when we use diversity on all of them, because for the sake of simplicity, we're just keeping diversity fixed. These stars are the next picks based on the different algorithm that we've used. And you can see, to be honest, that they vary a little bit. They are slightly different, but they have picked out some very similar points, to be completely fair. And so which of these paradigms you choose to use is up to you. My suggestion would be that it's not necessarily like the end of the world, but I think it's useful to have a bit of an overview of them, right? So hopefully that's kind of like a nice, like, oh yeah, I now feel like I understand that we've got like the least confident method that we could use, or we've got the top two gap method or the entropy method. And these are things which you can like have a little play around with, especially when you're dealing with many different classes. So if you do have an image classifier, for example, this is like a really good example where you might build something in a hackathon. You've got an image classifier and you want it to learn as quickly as possible based on, I don't know, objects that people bring to them, and you want it to say, oh, bring me this or bring me that or whatever. It's potentially going to be much more useful to use something like entropy than just least confident. Okay, that's my opinion. But it's worth experimenting with these in the case of not just a binary classification task. So I'm going to close that and I'm going to ditch it elsewhere if I can. Yeah, perfect, because I don't want to confuse our repository. Okay, and I'm going to just save that and say section 2. We're not going to have any code in section 2. It's just a nice little summary. Okay, cool. We could also do it with that committee idea. I do have a little picture of that as well, actually. Can I pull a picture directly through here? Let me see if I can, I might be able to. I don't know. Oh, my computer's just decided to give up and die. Okay, you know what, that's not going to work, so we'll keep moving for now. Right. 20 minutes left. Let's see what we can do. Great. There are some other bits and pieces which you might be thinking, okay, I want to use this in my hackathon project, but like, there's so many things to like think about. For example, batch size, right? What I would say is, as like a heuristic, keeping this between like realistically probably not any lower than 10, probably not much higher than 50 at most, I would say. Probably like the kind of 30, 25 range is like a good idea. Great. And is there anything else that's maybe useful to mention here? Oh yeah, so we could have the problem of like class imbalance. In this case, we've tactfully stratified, you might be like, oh, well, that's not very realistic. And it's not. What we could do is we could, in each set of picks, when we're deciding which ones to select, we could stratify then, and we could say, right, I want to cap how many can be picked from each class in each batch, right? You could also like weight the classes. You could weight the classes in the model or in the selection process. Like there's a bunch of different places you could do that. Ooh, I've got hiccups. I would say probably again, it's a case of like having a bit of an experiment and see what works. Additionally, like if you have no data at all in the first place, this would be like a cold start, right? You might want to just start looking at as diverse as possible set of points, and then slowly introduce your uncertainty. And so you could use like a scheduling function or something like that to kind of increase and balance those two, I guess, competing priorities. So that's a thought. Okay, so what I want to do is build a text classifier. I think this will be really cool, where we have some spam text and some normal text, in this case for messages, SMS messages. And we have a data set for this. I have the link open. Let me send it in the chat. Yeah, I think it's a cool application, right? Because you want it to work as efficiently as possible, but you constantly have data coming in when you've got text messages and so on, piling into your data set. Presumably you don't just have like a data set, you'll have them coming in kind of over time. And so this is what's called online learning. But maybe we've got like too much data coming in. This could be possible with like emails or text. And we want to like narrow down to the ones that are most interesting for labeling with a human person to do. Okay, so this is, I think, quite a realistic application of it, and hopefully we're going to get something cool working in the next 10 or so minutes. The data that we're going to be using is a pretty standard data set. Maybe I will put it up on screen. I've lost the data. Okay, this is fine. My data's gone completely out the window, so that's great. What I recommend is just opening it yourself. We'll have a little look at it by loading it in directly, so let's do that. Okay, I think we've got all of the inputs that we need already in this notebook, so let's put in a new line here, and then we're going to call this section 3, and we're going to say practical demo, and it's going to be active learning for SMS, text message, and spam. Okay, great. And some of this is going to be like a little bit messy because we're dealing with text data. So in the interest of, again, time, we might do some cheeky little bit of copy and pasting. This is the URL, so I feel like I'm allowed to copy and paste that. If you click this URL, it would just download the data directly to your downloads folder. You could find this URL on the link that I put in the chat as well. Cool. Okay, so this is not at all what we want. Just thinking about time, I feel like realistically we're not going to get through all of this, so let's copy and paste in some of the data loading stuff. So this cell here, which I've just pasted in, is going to be loading in all of our data. If, like, it's got a little fallback that if our data download failed, we can generate our own. Do we have pandas installed? Maybe we don't have pandas installed. Let's install pandas because we're definitely going to need that. if we have like issues downloading our data, we could use this like synthetic data set. I'm actually just going to delete all of that because we don't need to. And this is just like faffing about opening our URL up and downloading our data. So let's run this. It might have a bit of a tantrum because we don't have pandas installed yet. Okay, great. So it's worked. We've loaded in our data and we've got a Y value in our data frame, which is our label. And we are asking, okay, how many of our observations are spam? So we've got 5,000 messages and about 13% of them are spam. Fine, that's cool. Okay, that's enough for us to train on. Now notice that this is class imbalance, so we'll see how good this actually turns out. What I want to do next is I want to split our data up and I want to vectorize it. And this is using a library that we have not yet installed. It is, as always, from our... let's put it in here because I don't want to reload the data again. Imports. We'll call this extra imports. We're maybe missing a few. We're gonna from and we want feature extraction.text. Wow, look at that. That's crazy. Okay, great. And then let's also grab some other bits and pieces. What I want to use is something to make sure that our data is really actually diverse. And so we're going to import cosine distances, which is going to allow us to work out how different our data points are. Remembering our data points are actually text messages now. Working out cosine difference is a way of doing that really nicely. We maybe also want to import, we've already got accuracy score, but maybe we want a confusion matrix, which is, we'll talk about that when we plot it. It's just a plot, basically. There's also going to be something else that we need, and it's from SciPy, and it's apparently already satisfied, so that's good. We're going to import vstack, but we're going to import it as sparse. Yeah, we can call it sparse. No, let's just call it this. This is easier to type. And then we also want, these are allowing us to work with our text data in a slightly more efficient way. I don't want to get into the ins and outs of that, but it's basically just going to make our lives a lot easier. Okay, and so what we're doing here is we're splitting up our data. This is exactly what we've done before. We're stratifying it, making sure that our training data and our test data is representative of our class. Specifically in this case, we've got a class imbalance, so that's kind of important. And then we're going to vectorize our data, which is just a way of turning our words that we've got into vectors, which are like arrays of numbers. And then we're going to split it all up again, not just into our training and test data, but also into our unlabeled and labeled pools. Okay, and we'll give that a go. Great, so we can see that we've got a nice split across here. That's perfect. So seed in this case is just like how we're seeding our models originally. Like this is just so it's a warm start, so it's trained on some data initially. Okay, perfect. Great. Maybe we want to look a little bit at what our actual like data looks like. So we just run that. It's going to show us the top few rows, and we can see, yeah, it's just like text messages. So there you go. Not particularly exciting. We've got a Y label saying, okay, yep, this is spam, and then we've got our actual text. So perfect. Okay. What we need next is our functions that are going to help us work out our uncertainty and our diversity. And I'm going to paste these in and I'm going to talk through them because these are actually basically what we've just spoken about, right? So we've got a function that's making our classifier. We've got a function that's fitting it and getting the probabilities out, in this case, much easier than what we were doing earlier. Next, we are doing our different paradigms, our different methods for calculating how uncertain we are. And these are the least confidence scores. So we're grabbing our maximum top score, and then we're subtracting it from 1. This is just inverting it. So we're saying that something is, if it's larger, it's more uncertain. So if we had like 50% here, again, we'd have 50% there. But if we had like 90% as our largest probability on a class, we're very confident. And so 100% minus 90% is 10%. Pretty low, pretty certain, right? So larger is more uncertain. Great. And we're doing a very similar thing for the margin scores. And then we're doing some fun little maths for the entropy scores, so we'll move on past that. But that's doing that same thing. It's working out how spiky or flat our distribution is. Okay? This is how we're working out our diversity for our candidate set, i.e. the ones that we could pull from. We want to make sure that we're getting very different samples if we're pulling in diverse ones. And so we're doing that with cosine distance. This is just kind of how different the strings are from each other. Okay, so we'll run this. These are some useful helper functions. And these are basically what we discussed in section 2, but written out in code. So getting nice and practical. Great. Okay, so we've got our data. We've got our functions that are helping us decide how we're going to do our uncertainty. And now we're going to need our step function again. This time we're going to be using a sparse step function, and it's slightly different to the one that we had earlier. It's assuming a certain format called a CSR format, and this is using that VStack and CSR function. Well, the VStack function, at least, that we imported earlier. It's going to be easier to manipulate our data in this way. It's preferred for text data. So I won't go crazy explaining this, given we've got 5 minutes left. But it's basically more memory efficient to do it this way. And what we are doing is we are ranking according to our uncertainty and also our diversity here. And we, then generate our candidates and rank them and select them. So we're using basically all of these functions, and we're throwing it all into this function here, which takes a step by generating a new batch using the methodology that we prescribe as a parameter. Okay. So here the default is margin, and we are using diversity, the batch size of 32. And as before, these are labeled and pooled data sets. So we're going to run that. It's just another function for us. Okay. We also need to make sure that we have the code for our random learner, and also like our plotting and evaluation stuff, which we haven't actually done yet. I'm just going to paste this in. It's like very similar as before. We're also plotting a confusion matrix. I'll point out what that is at the end. Okay, so we'll run that again, 2, and then we have a long function that basically does what we had before. In this case, it is taking copies, so it should, if we rerun the cell, refresh. We need to make sure that we keep our constant names consistent. And then if we run this, we're going to get a very similar thing to what we had earlier. This time we've got a confusion matrix instead. And in this case, ham is just an actual message, and spam is a spam message, right? Something that we want to filter out, right? So we're basically building a spam filter. And let's say we're going to use entropy. Hopefully this is going to work now. This would be great. And let's select a new batch of 32. And it may work, or it may not. Okay, we get an error. This is fine. I don't think we need widgets here. I think we just need clear output. We've got this in a few places. Given we've got 4 minutes left, I'm gonna cheat a little bit. Oh. Please bear with me, hackers. And Okay, what I'm going to do is copy and paste in from another notebook where it has worked. Okay, perfect. Okay, so the code that I've used to build this in my little test is slightly different to what I've copied and pasted in here. So I'm going to go through and continue the copy and paste job. I think our evaluate and log function is the one that's throwing an error. We got 3 minutes. I believe I can fix this. What I'm going to do very quickly is check if we've got a stream after this. We do. Oh no, we don't. We don't have one for another hour. So I might overrun a little bit and hopefully give you all a sense of satisfaction as we see this put into practice on a real use case. So let's give this a go. So I think one of our issues that we're going to come up against is how we are vectorizing our data. And I think we've possibly not got it in the format that we need it in. And so I actually think we might have to go all the way back up to here and vectorize it slightly differently. So we've pulled in our data. Pulled in our data, then we vectorized it, and then we split it up and put it into the different pools that we need. Okay, great. Yeah, perfect. Okay. And then we need to grab our functions that we use to rank which points are most uncertain and most diverse. This is a slightly more comprehensive version that deals with the sparse data type. So we'll run that, and then in here I've got a different evaluate and log function that actually has this parameter, which we don't end up using, so that's funky, but I do know that this code works, so and I don't want to spend everyone's free time. I'm sure everyone's eager to get off debugging in the last couple of minutes. Yeah, this is fine. So we'll run this, and then we'll run this again. I'm pretty confident this time. Okay, right. If we select a new batch, hooray. Okay. So we can see now that we can select new batches, and immediately already we will notice that we got very high accuracy. So we only started off with, I don't know, started off with 417. Yes, 417 pieces of data, which was how we split it up earlier, right up here. When we loaded in our data, vectorized it and split it. Hopefully if we scroll back up, yeah, 417. So this is the seed, right? This is the warm start. So our model has some form of training. And we can see already that 417 pieces of label data has done like absolutely incredibly. 95% accuracy is very, very good. And this is right now just using logistic regression. So this is completely linear. We can see that it's got pretty good accuracy on, correctly predicting when something is in fact not spam. But there's definitely some cases where it predicts it as not spam when it is spam. And that's pretty bad. It predicts spam as spam reasonably well. And then there's like a tiny number of times it predicts something as spam when it's not spam. And this is the active matrix, and this is the random matrix. And we can see right now they're fairly similar. This one is definitely worse. We can see that it's got many more times, well, not many more, but like a decent number more that are predicting as actually not spam, but they are in fact spam. And so we can run this a bunch of times and we can see how it changes. And hopefully this is satisfying your desire to know, okay, is this actually better? Is using active learning actually realistically better in a real use case? And the answer is yes, it is. And we can see this here now very clearly. And we could try this again with, okay, that's great. So the reset button doesn't work. You should take this away and try and fix it. There you go. So if we try again with a different strategy, we can see also that they perform slightly differently as well. We can see actually that entropy is done really, really well here. I think this is pretty good. Yeah, we can see this here. We've got 56 predictions which are wrong. And here we've got 29. So pretty impressive. It also outputs a little summary of the messages down here. So we can see that some are definitely spam. And we can keep selecting batches and keep watching as our active learner improves quite substantially, in my opinion. So I hope that's satisfying, that little bit of theory that we discussed up here is actually demonstrably true and useful in a real world setting where we're classifying messages as either spam or not spam. And you can build a dashboard for this too. I've done this already. I might put it on my GitHub if anyone's interested, they can check it out. It's a pretty simple Streamlit dashboard, and you can put in messages and see whether the model classifies them as spam or not. So that's a potentially an interesting extension. And obviously this is spam classifiers is not a particularly original project idea, but if you are at a hackathon and you're building anything with models where it has to learn from data, this I think is a really useful framework for you to think about and incorporate. So with that, I will wrap up. I'm aware I am 3 minutes over. I'm going to take questions for the next kind of minute or so while I commit this. So this is what, section 3, final practical demonstration. Practical demo. Perfect. There we go. So if anyone wants to play around with this for themselves, you're welcome to do so. I hope that, again, as I said, has been interesting. And if anyone does have questions, let me know. I'm always floating around in the Discord too. So if you try building your own bits and pieces and you're having problems with some of the syntax or some of the kind of sparse matrices and stuff, you're like, what is this, Quinn? I want to know more detail. I can 100% help you out with that. So yeah, let me know if you have any questions. And of course, it's always great to have feedback. I know this was quite a conceptual stream and not necessarily a ton of building something, more learning and then demoing, but it's always good to know whether this is something you enjoy or whether you'd like to see more practical projects in the future. So please give me feedback. I'll pop the link in the chat. It's mlh.link/GHW feedback. And yeah, with that, I think I'll wrap up. I'm glad that people are learning lots of bits and pieces and that you're thinking it's cool as well. So yeah, with that, I'll finish. Thank you very much for joining me, and I'll catch you at the next stream. Oh, and the next stream is, in fact, a Gartic Phone mini event. That will not be a stream. That will be hanging out on the Discord and playing some fun games. So head along for that. That's in about an hour from now. So I'm sure I'll see some of you there. If not, at the next stream, I'm sure. All right. Goodbye, everyone. Thanks for coming.